All right, let's welcome you back to our next lab. Today we are talking about malware defense and persistence, and we will be looking at advanced APT, advanced persistent threat investigation. And what we want to do here is we want to understand how to conduct a complete investigation of compromised computer files, and we're going to discover information leakage caused by a computer. So in front of you, you see my computer here. This is our compromised machine, and was given to us. We are working as a SOC analyst, working in the position of a DFIR researcher, and we are trying to figure out what's going on with this computer. The employee is suspected of leaking information about their computer and the company, but the employee says they did not leak any information and that it was a hacker. If this was the if this was the fugitive, this would be a one-armed man. Also, Wireshark ran during the attack and perhaps captured information associated with the incident. So we are been brought in on retainer to prove that the employee did not commit the offense. So we're looking at the machine, it is starting up, and the first thing that we see suspicious is that it is listening on port 1337, which we know is the infamous leak port. We don't know why it's doing it, but we know command prompt is opening and it says it's listening on any port 1337. So first thing we want to do is, like any good defender, let's take a look at our auto runs, and we happen to have this file here in our download. So let's go ahead and extract it to here, and let's run auto runs, and let's see what we got loaded in here. So we got a couple things that are suspect. Right off the bat, we got command prompt running right here. And VirtualBox, that's fine. Those are guest tools. OneDrive is part of Windows. AutoRun.bat, we know AutoRun.bat is definitely suspect. We're going to be looking into that. We've got Microsoft malware, guest editions, and some other DLLs, underscore WoW64, WoW CPU, underscore WoW64 win. But what strikes me right off the bat is this autorun.bat. Definitely suspicious. And we can assume someone placed this file here because this is not one of your normal Windows files. So we will be investigating this. All right, so first things first is we know it's a bat file, which means we should be able to read this file. So if I right click on this one and I go to Process Explorer, let's see what happens. Let's see, anything happens there, and let's see, we got a little pop-up. It says, yeah, nothing special about there. Let's try to go to properties, and let's see what we got. So we have the location of this file, users, victim, app data, roaming, Microsoft Windows Start program. So we should be able to navigate to this path. So let's go ahead and let's do that. So we're going to go to drive C, and then users, victim, we see app data. Let's go ahead and turn on our hidden items is already turned on. That's why the app data folder is populated for us. Let's go to roaming, and we'll go to Microsoft, Windows, Start menu, Programs, Startup, and boom, here is our auto run that bat. All right, so we have that here. We can go ahead and minimize that one. And as we know, since this is a batch file, a bat file, we can go ahead and we can edit it and see what's in it. So right off the bat, we know this is a script and it's waiting for us. This echo off is what's showing us on the screen. It's echoing this to the screen. And we've got users, victim, pictures, NC for netcat, I'm guessing, and netcat.exe. And it's trying to listen on port 1337. So we got something to work with here. We see program is NC, which is netcat, run that command, definitely suspicious. All right, so let's go ahead and see what is going on here. So we want to find out more about this, and what we can do is we know it's running command DXC, so let's go ahead and use our PEID program and see if we can investigate this. All right, so we know we've got something in C, users, victim, pictures in C. So let's make a new Explorer window here. I'll go to C, users, victim, pictures. Look at that, in C. And then we got a couple of different files here. We know wget is the downloader, ICMP.sh, that might be ICMP shell. We'll confirm that later. But yeah, we got three different files here. But NC was the one that was definitely called out in this script right here. All right, so we got our executables. And again, why are these files in the pictures folder? Definitely suspicious. So let's see. Let's see if something else is going on with this netcat. Let's see if this file is being packed. So what we can do is use our PEID program to confirm if this thing is packed. So here's my PEID program. I'm going to go ahead and extract it to the downloads folder here. All right, once that is extracted, I'm going to go ahead and run as an administrator. And now I'm actually going to navigate to my netcat location. So let's go back to C, users, victim, pictures in C. Let's open up netcat, and we see right here. Um, let's see what we got here. So let's go ahead and do scan and run. So let's do normal scan. And we see that the file is packed with UPX, which we used in the past, so we can assume this one is malicious. So interesting. This thing is definitely scanned here. Got our offsets right here, UPX 0, 1, and 2. So definitely something inside of this netcat file here. So the next thing we want to do is we want to find out more about this, and we do see that we were also given a packet capture. Um, so what we can do is we can open this file up with Wireshark. So we are going to install Wireshark on our machine here. Oh wait, it's already installed, even better. Let's see if we can open up with the Wireshark program here. Let's go to more apps, and we can look for an app, and let's see if we can't find the Wireshark program here. Don't see it there. We'll do it like this. Let's go to Wireshark. Well, let's find our Wireshark. It says we have it installed here, but Wireshark Capture, open. Oh yeah, oh look, it's right there. Yep. Wait, program files, Wireshark. Let's see if I can't find that file. See program files. I do not see Wireshark here. That's okay. But what I can do is I can go ahead and install it. I want to say yes, next, agree, install everything. Let's do a start menu icon. Yep, yep. And next, and install. All right, so now if I click on my Wireshark Capture, we actually can look at the packets here. And let's see what we got here. We know that we were looking at port 1337, right? That's our elite port, and we do see some evidence of that already. We got elite right there. There's 1337, 1337. We got some net BIOS. Looks like they might be trying to query the name of a computer here. We got some more 1337 ports here. So we are starting to see, the port that was um, in call, or the port that was a question here. But what we can do is we can actually drill down by typing in IP port equals 1337. Let me do TCP port. There we go. All right, so TCP port equals 1337. So now we're just kind of follow this conversation and see what we can discover. And as you can see, we have lots of connections going on over this port. Looks like most of the traffic is coming from 10.0.2.8 and 10.0.2.15, the internal machines on our computer here. We can always try to analyze a packet right here. We got some retransmissions. If we double click there, we can pull up some more details about this stuff. And what we can do is we can also close that, and we can also say, follow the stream. So let's go ahead and try that. Let's go to follow TCP stream, and let's see what we get. So the first thing we get, suspect is we get who am I. We know in the class we've used that for enumeration, right? Trying to find out who the user is. So definitely funky there. We can go to the next stream and try to return some other information here. We see right here, look at this, we've got some stuff going on in the startup. And then, this is even better. Look at this. We have some enumeration, some directory traversal here. You see right here, they are in the app data roaming program startup. Then they're going back and they're going back and they're going up a whole bunch of folders here into the app data. And then you can see them actually going into CD pictures. They are seeing what's in there. And then they're actually making a folder, looks like the netcat folder here. And you see right here, they've got, yeah, look, here's here's them trying to download the file using wget over that IP address, right? They're like trying to get this file here, ICMP, SH, I'm guessing that's shell. And then right here, we get the command and you get a connection failed, bad file descriptor. And then you see them also trying to get some other files right here. And so interesting. So it looks like we definitely had some connections here. We had some transfer. We had some success here. And yeah, it looks like we definitely have um, some lateral movement and some stuff has been compromised. So interesting stuff here. So we know we see we've got these files ICMPSH, UCMPSH, and if you don't know what it is, let's go ahead and let's try to see what this is. So first thing we're going to look for is, let's see if we can't figure out what ICMPSH is. So let's try this, ICMPSH. And let's see, oh, look at that, simple reverse ICMP shell. Sometimes network admins make the make the penetration testers' life harder. Some of them do use firewalls for what they're meant to. Surprisingly, allowing traffic only onto known machines, ports, and services. Ingress filtering. Okay, that's good, right? That means we're doing our job and we're making our systems harder. But it says ICMP is a simple reverse shell with the Windows 32 slave and a POSIX compatible master. So basically, yeah, this is definitely to get inside of some type of computer here. If we drill down further into the GitHub page, we're seeing that, yeah, this is definitely something to do with reverse shell. Let's go ahead and go back here. Looks like this page might not be loading anymore, but we can go back, ICMPSH, and we can try a different web page right here, maybe something more recent here. Here's something from the darknet as well. Look at that reverse shell, and we got some commands here. Look at this. So definitely suspect, definitely something we do not like to see. So based off of this, right, we know that we're trying to get a reverse shell here. We know it's over the ICMP protocol. So we're seeing ICMP SH's shell. So we were correct on that hypothesis. Next, we would want to take a look at ICMP traffic, right? Wouldn't that be something that we would want to try to pivot on here? So let's keep on looking here and seeing what we can discover. So let's go ahead and clear out our filter here. And let's see what we can find here. So look at that. We've got some ICMP traffic here. And the cool thing with Wireshark is you can always filter or add on to stuff based off of the ICMP filter as well. So let's take a look at this traffic and see what we can discover here. We can say apply as filter. We can say selected. We can follow that stream and try to see what we can get right here. So we can keep on going, see if we detect some stuff here. We might get lucky, but again, our job right now is to investigate all of this stuff right here. So let's close out our filter, go back into here, and let's keep on looking here, see what we can find here. That's the one we were just looking at here. And if we keep looking, right, we're seeing some more destination unreachable here. And then we got some more destination unreachable. And then let's keep on going. Destination unreachable here. And of course, we can still follow the stream, see what we can figure out. But, looks honestly, right, we were brought in to investigate this, and we do have our desktop name. We got some information. We saw that this thing was definitely running some type of reverse shell. And what's going on here? So did the employee, actually do this? Well, we'd be hard pressed to say. I would say right now, unless this employee has this skill set um, to actually do this over ICMP, if they have that much network knowledge, then yeah, sure, the employee could be responsible for the leak. But this is what we know, right? We use we use Netcat to run the shell. We use wget to download the ICMP shell, and then they use ICMP to try to get data out of the company network because they were not blocking the ICMP protocol. So if the employee wanted to leak end information, they could have done so without running the entire process. So maybe this was done to make a red herring. Maybe it was done to create some alibi and deflect suspicion from the employee. But we can only conclude that maybe they um, ran this, but it's probably not likely. They could have clicked something, and once they clicked something, this reverse shell could have spun up on its own, right? And it was doing it in a location that the victim would normally not look at. So that is the end of the lab. I would encourage you to investigate the ICMP shell and see how other attackers try to exfiltrate data when they have, a tough perimeter to break through. All right, I'll see you in the next one. Bye.